Okay guys, let's evaluate some log functions. Some more. So, first of all, if you watched the video, I already did this once before. You have to remember that natural log and e are inverses of each other. As a matter of fact, a natural log, guys, is really log base e. E is a special number. E to the 1, for example, would be 2.71 something. I forgot. You could do it on your calculator. What's important is, since they're inverses of each other, they cancel each other out. And notice I'm just left with 4. Okay? So natural log and e will cancel each other out. Now, let's go to this number 22 here. Notice there is no number there. So if there is no number, you have to remember that number really is a 10 there. So this is the same log that you would have on your calculator. Your calculator, that log button is power 10, base 10. But anyways, to solve this, we know it's some value x. So we know it's a base 10. So 10 to some x power has to equal 1,000. That's how you read log functions. The base tells you basically what its inverse power function is. In this case, it was 10. Now, guys, hopefully you could do this in your head. Since 1,000, for example, has 3 zeros, you should know 1,000 is 10 to the 3, right? In other words, if I did 10 times 10 times 10, I would get 1,000. So, if 10 to the x equals 10 to the 3, same base, 10, right? That tells you that x must be 3. All right, once we do a few more, hopefully you'll get this down. This one right here, guys. Notice the base is 25. So 25 to some unknown x power has to equal 125, okay? Now, the trick I've been trying to show you is, can you make both of these numbers the same base if you needed to? Aren't they both 5 powers? For example, do you agree that 25 is really a 5 squared? See what I did there? Equal 125, I hope you know, is a 5 to the 3rd power. In other words, 5 times 5 times 5 is 125. The bottom line, guys, you got to know your squares, you got to know your cubes for sure. But if you agree with that, guys, notice I just made them both in the same power base. So that means, common sense at least, that and that, if they're equal to each other, have to equal each other, right? So I know that 2x has to equal 3. Once I divide by 2, x is 3 halves. And your teacher should accept the improper fraction. Matter of fact, they prefer it. 3 halves. You don't have to divide this and make it 1.5, for example. Okay? All right, let's take a look at another one. Notice this one has a base 64. So 64 to some unknown power or base exponent has to equal this number 4. So again, most of you probably can't convert the two, except hopefully you know your power is good enough. Do you guys know, for example, that 64 is really a 4 to the 3 power? And I know what you guys are thinking. Yeah, how am I supposed to know that? Well, that's why I'm telling you. You better know your cubes. Okay? As a matter of fact, let's go through them again. 1 cubed, of course, is 1. 2 cubed, you should know, is 8. 3 cubed, you should know, is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. Usually they don't go higher than 6. Okay? But anyways, if you agree with me that 64, follow the purple, is 4 cubed, look what we have here now. I have 4 to the 3x equal to 4 to the 1. That means 3x has to equal 1, right? Or x has to equal 1/3. All right, take a look at this one right here. Notice the 1/2 base. So 1/2 to the x power has to equal 128. So how are we going to do this one? Well, one trick is, do you guys agree that 1/2 is really 2 to the negative 1 power? In other words, do you know your negative powers, right? That negative 1 is what we use to do reciprocals, right? So 2 to negative 1 is 1/2. Now, if you agree with that, we have 2 to the negative 1x basically equal to 128 here. Now, 128, guys, is a 2 power. Just take your calculator and go 2 times 2 times a 2 times a 2 times a 2 times another 2, and finally times another 2. And if you kept timesing by 2's 7 times, you know you would have gotten 128. So 128 is 2 to the 7. Yes, I know. If you don't know your powers, you're in trouble with these. I don't know what else to say, guys. Okay? But actually, we could. I'm going to show you, matter of fact. But anyways, to check our answer, let me finish it up. So do you guys agree, since we now made them both 2 powers, negative 1x has to equal 7. So if negative x equals 7, x must be negative 7, right? Now, I want to remind you of something. Let's say you're allowed to use your calculator. Okay? Well, guess what, guys? Do you agree that, look at this right here. Could I not have taken this right here, follow the green, and using change of base, say that's really the log of 128 divided by the log of 1/2. Could I not have done that using change of base? That's how I'm going to do it on my calculator, right? Well, the log of 128 divided by the log of 1/2, use those parentheses now, is negative 7, just like we got right there. And this one, if you didn't notice, I did this one as well. Follow the purple. Okay? Do you agree I could take this right here and change it to the log of 4 divided by the log of 64? That's using change of base. Well, guess what? The log of 4 divided by the log of 64 is 0.33333, which hopefully you recognize is 1/3. 1/3 is 0.333 repeating, right? And that's exactly what we got there. All right, guys, hopefully this is helping and it's making sense, even with these crazy numbers. All right, let's do a couple more here and call it quits. This one, because of the 3 power, we know 3 to some x power. And if you're allowed to, guys, just do it in your calculator correctly. You can verify your answers, just like I showed you on the last 2. But anyways, 3 to some mysterious x power has to equal 1 over 243. So what do we do here? Well, we have a 3 to the x power. Can we change this to a 3 power? Guys, just take your calculator and go 3 times 3. Don't you get 9? Times it by another 3. Don't you get 27? Times it by another 3. Don't you get 81? Times it by another 3. Don't you get 243? So in other words, 3 to the 5 is 243. So do you guys agree? If that's true, this is 3 to the negative 5. Because it's 243, but we did a reciprocal of it, right? So if you agree with that, I now know that x is simply negative 5. All right, one more. Guys, because of the 6 power, I know I have 6 to some mysterious unknown x exponent. That's supposed to be 1 over 216. Now, guys, we just talked about 216. Isn't 216 6 times 6 times 6, or 6 to the 3 power? Well, we therefore have 6 to the x equal to 6 to the negative 3. Again, notice I have the reciprocal of 216 here. Again, if you agree 6 to the 3 power is 216, I have 6 to the negative 3 there. So if you look at what I have here, that means x must be negative 3. Again, guys, I could have verified if I did this correctly using parentheses on my calculator. This is change of base. You would get negative 3. You ought to practice with your calculator again a little bit, by the way. So, guys, hopefully this helps you out with your logs a little bit. Guys, they're weird because you've never seen them before this year. Keep that in mind. A lot of the stuff that I've had to been able to teach you before this coronavirus nonsense, okay, you've actually seen a little bit or most of it before. Logs you've probably never ever seen before, so you need to put a little extra practice in them, all right, to get good at them and understand them better. Okay, guys, I'll see you around.